Hello, Assalamualaikum and hello. So I will show you back how to solve this voltage regulation. So if you draw the circuit diagram is something like this. Okay, you have resistance, you have inductance. Okay, this one is this one referred to the primary side. So this one is 0.08, this one is 0.027. Okay, and you get V1 is 200 volt. Okay, then you have this one is V2 plus minus V2 bar. Okay, don't forget this is referred to the primary side, so this is V2 bar. So I redraw this back. Okay, it's something like this. So V1 is 200 and V2 bar is unknown. Okay, so it's something like this. Okay, so when there is no load, okay, when there is no load, okay, so basically what happened is this one. Okay, and don't forget this is I1, okay, you have this one, Req, Xeq, I1. Okay, when no load, at no load, ZL will be infinity. Okay, it means that it is no load, open circuit. When there is open circuit, I1 is just equal to 0 because there is no path for the current to go. Okay, so this is V1, this is V2. Okay, when you do a Kirchhoff voltage law here, okay, automatically you get V1 is equals to, and this one is 2 bar, V2 bar. Okay, at no load. So this one will become 200 volt. Okay. So during the full load, so what happened is, okay, I draw this back, okay, and you get this one, Req, Xeq, V1, okay. This one has load, okay. This is ZL, okay, this is ZL bar, okay, plus minus V2 bar. Okay, and this one is also, okay, I forget, ZL bar. Okay, so what happened is you have, okay, you have the current here. At full load, you have to follow back the capacity here. Okay, you see here, this is the rated. Full load means that it follows the transformer rated capacity. This is the rated capacity. Okay, so this is S rated equals to 10 kVA. Okay, so 10 kVA S rated. Okay, from S rated, okay, and then you have the hour factor. Okay, just calculate the current first. Okay, so I1, okay, at full load means that this thing use 10 kVA. Okay, that is what it means that by full load. Full load. Follow transformer, okay, rated capacity. Okay, so based on this, you get I equals to I1, okay, I1 here equals to S, okay, divide by, okay, divide by V2 bar. Okay, because this resistance use 10 kVA, okay, and the current is here, okay, this is the current goes here, okay, and the voltage you need to use this. But the problem is right now, okay, if you assume this is 200 volt, okay, you don't know what it is, okay, because in the question we tell that the voltage, okay, is 200, and this one we don't know, so it is hard to calculate. And for voltage regulation, it is not important we follow the input voltage or not, because we just want to know the difference. Okay, want to know the difference, then apply it into the equation. So how to solve this easily? You just change, instead of the input is 200, you assume the output is 200. That's it. As a result, you can get I1 is equals to 10, okay, 10 kVA divided by V2 is 200. V2 bar is 200. Okay, and then you get, so cut, you get 5 ampere, correct? Oh, I forget another 0. Okay, 10 kVA, so 50 ampere. So you get this one. And then how about the angle? Okay, so the angle, we assume that this one is reference. Okay, we assume this is reference. So, and the power factor here is 0.85. Okay, if you look back here, it is 0.85 at full load. Okay, so what happened is, so PF equals to cos theta V minus theta I. Okay, correct? And then 0.85 equals to cos theta V is 0, because we already assumed this. Okay, and then minus theta I. Okay, and because this is lagging, as mentioned here, okay, remember lagging, okay, lagging is positive, okay, leading is negative. So if you calculate this, so if you rearrange this back, is theta I is equal to negative cos inverse 1 0.85. So use your calculator, find the cos. You have to shift cos to get the cos inverse. So you get negative 31.79 degree. So you already get the current here. So the magnitude is 50 and the angle is negative 31.79. This is the current. Okay. So you already know the V2 bar. Okay, V2 bar. And you already know the V. Okay. The I1. So what to do next is you have to find V1. Okay. So V1 here. So you don't know this. What is V1 right now? Because you already assume that this voltage is 200. So you don't know what is the voltage here. Okay. The output, the V2 bar is 200. Okay. So V1 is unknown. Okay. So when you don't know this voltage, so you have to calculate V1. Okay. And what happened is, okay, what happened is, as I mentioned before, okay, when there is open loop, V1 is equal to V2 bar. So basically you have to use this new category, okay, this new condition where is the V2 bar is 200. So means that equals to, okay, V2 bar is 200. So V1 is, okay, V1 is, you calculate here. Okay. So you have to recalculate V1. Is basically what I'm trying to say is you have to recalculate V1. So basically V1 is just I 1 ZEQ plus V2 bar. Just do a Kirchhoff voltage law. Okay, positive and negative, positive, positive, negative, positive, negative, because the current goes into positive for load. Okay, for resistor, inductance, and this one positive, negative. Okay, so for this case, you get I1 is 50 angle negative 31.79, okay, degree, and then the ZEQ is, okay, you check back the question, okay, 0.08, okay, 0.08 plus J 0.027, okay, 0.027, okay, you get the ZEQ. Don't forget the J, okay. So ZEQ is basically REQ plus JXEQ. So don't forget the J. And then plus 200 angle 0. So you get V1. Okay. And this one, V1 is, okay, this V1 is basically the new V1. Okay. You cannot use the question, okay, because you already assume this load has the 200 volt voltage because of this problem. Okay, because of this problem, because you need V2 bar. So you just assume this and you calculate the V1. You cannot use the old one. So this is the old one, old V1. Okay, and then this is the new V1. New V1. Okay. So basically from this, you can know that V2 bar at full load, okay, full load is basically 200, okay, 200 volt, because we already use it here, okay. But how about the V2 bar at no load? So we recall back this one, okay, remember this one, the original one, okay, this one, okay, when there is no load, V1 is equal to V2 bar. So at V2 no load will be equals to V1 new voltage. Okay. So for this condition, you have to copy back this. Okay, if you calculate this, so V1, okay, the new V1 is equals to 204.11 angle. Okay, make sure you use the polar form. Okay, this one is negative 0.27. Okay, and when you want to calculate the voltage regulation, only take the magnitude. So what happened is your new is 204.11. This one is no load. Okay, at no load, new no load. This one is the new. Okay, the previous one is the old one. So this is the full load, of course. This one is the new. Okay, the old no load is 200, but the new no load is 204.11 volt. So refer back to the formula. Okay, copy this. Okay, you already have this value, and then you just use it. So percent VR is equals to V no load. Okay, this one V no load. Okay, 204.11 no angle, minus V full load is 200. Okay, divide by no load. Okay, 204.11 multiplied by 100. So you get the answer is, so you get the voltage regulation is 2.01%. So that is how you do the voltage regulation. Okay, so I think most of you confused on this one. Okay, the switch from the V1 equals 200, but then V2 bar is equals to 200 instead of, and we have to find the new V1, and then from the new V1 we get the no load voltage. Okay, the new no load voltage. Okay, remember this. Okay, this is the confusion happen. Okay, try to understand this and you can answer this question.